Hey builders, welcome to the complete guide for the Coinbase Developer Platform Staking API. Staking is essential for securing proof of stake networks and allows users to earn rewards on their assets. But building staking integrations is complex. Every blockchain has its own rules, transaction formats, and operational quirks. That's where the CDP Staking API comes in. It's a powerful abstraction layer that lets you build multi-chain, non-custodial staking integrations with a single unified API. In this tutorial, we'll build a simple web API from scratch using React and TypeScript. You will learn how to get the API keys, understand core concepts, and do your first staking operation on the Hoodi testnet. Let's get building. First, let's get our project setup ready. So we'll be using Next.js to create a full stack application. So I'm already on my terminal over here. You can just navigate over to your terminal. And I'll be using this command, which I already have over here. npx create next tab at the latest. Name will be my staking app with the text configuration, Tailwind, and other configurations. So I'll just click enter. So would you like to use ESLint? Yes. I'll just keep to no over here for SRC directory. Next dev, yes. We don't want to customize the import alias. And yeah, now it will initialize Next.js project with React. So we'll just wait for this. Once the scaffolding is done, now we will install on the Coinbase SDK dependency. So I already have the command over here to install the dependencies. So first of all, we will install the Coinbase CDP SDK, and then we'll install ethers for other blockchain utilities. So once it is done, I'll click enter. This will install other dependencies as well. So it might take a bit longer time. Once that is done, let's just redirect back to the Coinbase Developer Platform console and get our API keys from there. So to use the CDP staking API or any kind of CDP services or tools, you will have to first get the API keys. So you can get the API keys from portal.cdp.coinbase.com. So just navigate over to this website and you will be first prompted to log in using your credentials. So you can use your existing Google or any email credentials. So once it is done, you will be navigated to such a dashboard where you will see the project ID and you will see some get started initial first steps as well. So here you can just navigate to the API keys console, and here you can just create another API key. So click on this create API key, blue button over here. Just give an API key name. I'll just give this a staking API key. Once that is done, check the API restrictions as well. These are very important configurations, at least when you're working on production. For now, as we are testing, there aren't any issues, but when you're working on production, make sure that all of these restrictions are properly set up. So, for example, if you want only read-only setup for your API, just make sure that it's only kept to view. And if you want any trade or transfer executes or any trade or transfer functionalities as well, you'll have to select this as well. So we definitely need trade and transfer as we'll be conducting a staking operation through this API key, but we don't need this accounts and policy setup. So make sure that you are setting up these restrictions properly. Once that is done, we can go to the advanced settings as well, check this. So make sure that the signature algorithm is always set up to ED25519. So this is by default the CDP staking API or CDP any kind of API signature algorithm. So make sure that it's set up to this recommended signature setup. So once that is done, we'll click on create and download, and it will ask for my two-factor authentication. So I'll just use this. So once that is done, it will prompt to download your API keys in a JSON format. Just download it in your most safe part of your system. Make sure that you keep that folder private and you don't keep it into a public access or something like that. So I'll just save this, and that's it. You have got your API keys. Just make sure that you copy these credentials and you can use these credentials for accessing the staking API. Before we start writing code, let's understand two fundamental concepts: staking modes, shared versus dedicated ETH. The staking API supports staking to Coinbase validators for both Ethereum and Solana networks. For Ethereum, there are two modes: dedicated ETH staking. This for staking 32 ETH or more. It's called dedicated because it provisions new Ethereum validators in Coinbase infrastructure on your behalf and stakes your ETH to them. Second, shared ETH staking. This for staking any amount of ETH and is useful for enabling users to stake much less than 32 ETH. It's called shared because ETH from multiple users are pulled together and staked to a Coinbase validator that's shared across many users. The single most important concept in the API is the staking operation. Think of it like ordering a custom built computer. You don't get the product instantly. Let's go through this diagram and see how all of this works. So we have the app, the staking SDK, and the Coinbase staking API. So first, we have the initiate process, where we call the build stake operation in the staking SDK. The staking SDK then starts its internal process and calls the slash stake slash build on the Coinbase staking API, and the staking API returns the staking operation with the status initialized. The staking SDK then returns the staking operation object to the app. Once that is done, the app initiates the second process, which is the poll process. Here, the app calls the operation.wait method on staking SDK. So once this wait method is called, a loop is called on the Coinbase staking API slash stake slash operations on the get method with the ID, and this polling loop is handled by the wait method. So you don't have to do any manual processes to handle this Coinbase staking APIs. The SDK handles all on its own using the dot wait method. Once that is done, it returns the status processing, and we'll use the slash stake slash operation ID. And once the whole status of the processing status is done, the status is returned as complete. The staking SDK then will resolve the wait method successfully, and the app can now access unsigned transaction from the completed operation. This asynchronous flow is key because some operations like provisioning a new validator can take time. So our quick start will be using the shared each taking method. So this is the most quickest and the easiest way to get started with. To testing, you will need some testnet ETH in your wallet. The official testnet for this quick start is Ethereum Hoodi. So you can just navigate to portal.cdp.coinbase.com/product/faucet. So it will navigate to the Coinbase Developer Platform faucet. So here, just to keep the network to Ethereum Hoodi. And as you can see, the faucet also supports various of the test networks like Base Sepolia, Ethereum Sepolia, and Solana Tailwind as well. So I'll just keep this to Ethereum Hoodi. Token will be ETH. And here you can just copy the address that you want the testnet funds to be sent. So I'll just paste my address over here. I'll just claim the 0.001 ETH, I guess. And you can view on Etherscan as well. So hoodi.etherscan.io. It's a Hoodi testnet transaction. And once the transaction is confirmed, we will receive the funds as well. So yeah, this way you can easily get the testnet funds from Coinbase Developer Platform's faucet. Now for the fun part, let's start building a secure staking application using Next.js. So before that, make sure that you have kept your CDP API key.json in the staking application folder so that the application can directly become from this JSON file. And also make sure to properly update your Gitignore with this Coinbase Developer Platform API keys. So properly updating Gitignore will make sure that you don't accidentally commit this or push this keys to your public GitHub repositories. So make sure that you have added the CDP API key.json to the Gitignore as well. So once that is done, now let's start building out our application. So first, we'll build out the APIs that we will need in the Next.js application, and then we'll build our app page. So let's start building the various Next.js routes that we would need for this application. So the first route would be the stake route, where we would use that route to stake our testnet ETH on Ethereum Hoodi, and the second route would be the one which would show the actual stakeable balance from the wallet address. So go ahead and go to the app folder, and in the app folder, create another folder known as API folder. And in the API folder, there will be two folders. One is the balance folder, and second is the stake folder. So first of all, in the stake folder, we'll create another file known as route.ts. So once you have created route.ts, the Next.js application will automatically pick up the route from here. So here, now we can build our first Next.js API for the application. So I already have the code for the staking route here. So I'll just go through the code one by one and go through the whole code and explain you how the whole API works. So we have the code over here. So first of all, we have the imports from Next server and Coinbase SDK imports. So these are very important imports to make sure that we have the proper API configuration setup. So Next server imports and imports like Coinbase external address, stake options, more imports from Coinbase SDK, Once that is done, we will craft out a post request over here. So first we will get the wallet address and amount from our request, and then we will configure the Coinbase SDK with our API keys. So we have already kept the API key part forwarding to our CDP API key.json. Next, we will use the Coinbase.configure from JSON option, and the file path will be the API key path. Next, we'll create an external address on the Ethereum Hoodi testnet. So we'll use the external address import from Coinbase SDK to create an external address on the Ethereum Hoodi testnet, as we are conducting all our operations on Ethereum Hoodi. Next, we will check the stakeable balance. So here we'll create another function known as a stakeable balance or variable, and we'll use the address.stakeable balance to get the stakeable balance. Once that is done, we will build the stake operation using address.build stake operation, and here the various parameters would be Coinbase sh.eth variable and stake option mode.partial variable configuration from the Coinbase SDK, and then we will get the unsigned transaction payload from the Coinbase staking APIs. After that, we will return a Next.js response or next response.json with all of the various parameters that we got from the unsigned transaction. So if there is a success, it will make sure that the success is true with the operation ID, stakeable balance, unsigned transactions, uh, and the transactions body. And if there are any errors, it will also make sure that the errors are also caught properly and displayed on the console. So that's it. We are done with the first route. That would be the staking route. Next, we'll create a small balance route as well to show the staking balance on the app UI. So let's start creating the balance route.ts. So I'll just create another file over here, route.ts. And I already have the code over here. This code is just a part of the staking route itself. We are just making sure that we have proper file structure over here in our Next.js application project. So I just pasted the code over here. So first of all, we have some imports from Coinbase SDK and Next server, which we have already discussed before. And after that, we have the post function. So this would be our post API. So we will get the wallet address from uh, the request. Then we'll use a CDP API key.json to get the API keys and use Coinbase.configure from JSON to construct the API keys and configure the API keys. Once that is done, we'll use external address import from Coinbase SDK to construct the address on Ethereum Hoodi testnet. Once that is done, we'll use address.stakeable balance to get the stakeable balance and return the response as success with all of the various parameters. And we do have a error checking block as well to make sure that if there are any errors, they are properly displayed in the console as well. So there is nothing new in this. This is just an part of the stake API that we created over here. So as you can see, we did check the stakeable balance here as well. This is just to make sure that we have proper APIs available when we are displaying the balance on our app UI. So now that we're done with the staking API routes, let's now install the various dependencies that we would need for wallet connection in our application. So we would also give wallet connection so that we can send this staking transaction and see how it works and view that on the block scan as well. So I already have the dependencies over here. So we'll install WAGMI and VM for the blockchain utilities and React hooks, and connect it is the main package that would set up the wallet dependencies, and type check React query for setting up React query. Legacy PR dubs to make sure that we don't have any issues or errors related to NPM packages. So I'll just hit enter. So we're done with the installation of the packages as well. So now let's go ahead and set up the providers.tsx for wrapping our application. So I'll just set up providers.tsx, and I already have the code over here. I won't explain this in detail as this is much towards a staking tutorial. So this app providers.tsx, we have some imports from WAGMI and connect it. After that, we set up the config of WAGMI on Hoodi testnet. And once that is done, we set up query client and set up the Web3 provider component where we wrap the entire application with the WAGMI providers and query client providers as well as connected providers. So that's it with the providers.tsx setup. Now we can move to the main UI and build a staking tutorials UI as well. Before we move to the UI part, let's make sure that we have set up this configuration in layout.tsx. So just go to layout.tsx and make sure that you have imported the Web3 provider from providers.tsx and wrap the application with the Web3 provider. So this will make sure that the configuration is set up before we set up the wallet connection in UI. So this would complete the wallet connection and provider setup part. Now we can move to the UI and set up the UI along with the wallet connection. So please go ahead and create a staking tutorial.tsx file in your application. So here is where all of the logic would reside for the UI. I'll just close this on as well. So first of all, we'll start with the imports and the helper type objects that we would need for this application. So I already have them over here. Let's go through this and see how they work. So first of all, make sure you're using use client to make sure that we do not deal with any server or client related errors related to Next.js. After that, we have the imports such as use state from React for setting of states, and then connect it button from connect it so that we can initiate wallet connection in our application as well. Then we have use account and use send transaction from Valme for sending the transaction and broadcasting the transaction on Hoodi testnet. And after that, we have base error and pass transaction utilities from VM. Once that is done, we have a helper type for our transaction object as well. So this is what the unsigned transaction would look like. This is just a helper type. So we would have fields like to, from, value, data, nonce, and various other gas fields like gas and max fee per gas. And then we have the chain ID, which would be a number where we set up the Hoodi chain ID. So once that is done, we can move to the main component of staking tutorial.tsx and set up the route management as well as the UI. So now moving on to the staking tutorial function. First of all, let's set up the use state variables and the global variables that would be needed by this function. So I already have them over here. So first of all, we have the amount. First of all, we have the amount global variable and the global use state variable for amount. Then we have status, stakeable balance, unsigned transaction, operation ID. Operation ID is something we get from the API routes set up in the Next.js routes like balance and stake routes. And then we have the error and the transaction hash use state variables. So this should cover all of the state management that we would need in this UI. And after that, we have the user account and use sent transactions setup where we take the address and is connected from user account and send transaction from use sent transaction. So this should cover all of the global variables that we would need for setting up this code. And after that, we can move to handling the APIs. So in the API management function, we would have first the check balance function. So I already have it over here. So first we would have the check balance function where we use the balance route from Next.js routes. So here we make sure that first of all the wallet is connected. If it's not connected, it will show that please connect wallet first. And then we set up the status. So this would make sure that the user is known of the state changes. So here it will show the user checking stakeable balance and set a use state variable as well. As there is no error, it would be an empty string. After that, we have a try catch block which manages the API. So here we get the response from the fetch using the fetch function, and we will use the slash API slash balance route over here with the method post and headers. And in the body, we would send the wallet address that we got from the use account use state variable. So here we'll set up the wallet address. And once that is done, we'll await for the response and we'll get the JSON from the response. And if the response is not okay, it will throw a new error. And if all of this was successful, it will set the stakeable balance and set the status showing the user that this is the stakeable balance. And after that, we have the error catching block where we set up the error and the status, making sure that user is known that there was an error and the operation to check balance was failed. After that, we would have the main staking operation API management route. So here we would handle the staking operation. So now we're done with the check balance function. So now let's set up the transaction building for staking transaction using the Next.js API route. So I already have the function over here. This is an important function. So we make sure that you are able to understand this properly. So I will go through this line by line and explain you how the function works in overall. So first of all, we'll make sure that the wallet is connected or not. So if it's not, it will set the status to please connect wallet first. And then we set up the various use state variables. So here we set up this we set up the status building staking operation and then set error, set unsigned transaction, set operation ID, and set transaction hash. So we would be using all of this state variables in this function. After that, we have the try catch block, which mainly handles the API routes and its response. So first of all, we get the response from the slash API slash stake route, and here the method would be pushed along with the headers, and the body would be wallet address where we send the address that we got from the wallet connection and the amount of stakeable balance. Once that is done, we'll get the response from the API route in JSON format, and we'll make sure that we have got the response. And if not, it will throw a new error. And once we have got the response, we'll set the operation ID to data.operation ID that we got from the API route. Once that is done, this is the main and important part of this function. The unsigned transaction is a hex encoded JSON string. So it's not a normal JSON format or JSON formatted response. It's a hex encoded JSON string where we'll first decode from hex to string and then pass the JSON from it. So we wouldn't directly pass the JSON. We'll basically decode the hex and then we'll pass the JSON. So this is a very important step that many of the developers miss out. So make sure that you are passing the unsigned transaction properly. So we will first decode from hex to string. So we'll take the hex string from data.unsigned transaction, and then we'll pass it to a JSON string where we use buffer library, and we'll use buffer.from hex string, and the format would be hex, and this would pass it to the string format UTF-8. So this is the very important part of this function. Once that is done, then we can safely pass the JSON and get the unsigned transaction. So we will get the pass transaction using JSON.pass where we will pass the JSON string, and then we can console log it to make sure that we have successfully decoded the transaction. And if all of this was failed and there was an error, we will make sure that the error is cached using the catch block, and we can make sure that the error is set up in the console and throw a new error invalid transaction format. Once that is done, if all of this was successful, it will set the unsigned transaction to pass transaction and set the status check operation built successfully. And we'll set up the console log as well. After that, we have the catch block where we set up the error and the status. So we had two try catch blocks over here. One is the passing unsigned transaction passing try catch block, and then the main try catch block. So this was a pretty complicated function, but this is the most important function for our application over here. And making sure the unsigned transaction passing was successful is the main part of this function. So make sure that you take special care for this. And once that is done, now we can build the function that would send this operation and broadcast this on the Hoodi network. And we would use the use send transaction use state variable over here. So I already have the send and broadcast function over here. I'll just push it over here. So the next step would be to sign and broadcast the transaction. So this will sign and broadcast the transaction in Hoodi testnet. So first of all, you make sure that the unsigned transaction object is available. If not, it would set the error to no unsigned transaction available to sign. And if that is successful, we'll set the status, error, and transaction hash use state variables. Once that is done, we have the try catch block where we handle the transaction from Coinbase SDK. So this is the format where the transaction is from Coinbase SDK. So here we have the transaction request with the various fields like to, data, value, gas, and max various other gas fields as well. And then we have the chain ID. So here we'll pass all of this and construct this into transaction request. After that, we have the console log sending transaction. And once that is done, we will use the send transaction function with the two internal functions on success and on error to handle successes and errors. So here on success would set the transaction hash and set the status. And on error, it would make sure that the error is properly propagated, and here it will show the transaction error. And if it's an instance of base error, it will set the error to the short message, and if not, it will set the error to the normal message. Once that is done, we set the status as well, and then we have the catch block of the main function where we set up the console errors and the status and the set error use state variables. So once that is done, now we can finish this off with the return component. For the return component, I already have the function. I'll just push it over here. It's not much. It's just a short return component where we set up the connected button and the transaction objects. So first of all, we set up the connected button, and then we set up the various state management UI, like making sure that if the wallet is connected, it shows the is connected address and the amount to stake. And then we have the check balance function usage as well. And after that, we have the build stake operation UI, where we make sure that a button is set up for building the stake operation. And after that, at last, we have the unsigned. After that, unsigned transaction sign and broadcast transaction as well. So here we'll sign and broadcast the transaction to the network. And after that, we have some basic styling to finish off this page. So with that, we are done with the staging tutorial.tsx TSX page, and now we can set up the staging tutorial.tsx page on page.tsx and test out this application. Just go ahead and in page.tsx, just set up the staging tutorial.tsx. So this shouldn't show any errors. Yep. So in page.tsx, just in the home function, just make sure that you're returning the staging tutorial.tsx page, and this should now become the default page for the application. So now let's just start the application. A new instance of the terminal, and here let's start up the development server npm1 dev. So it's showing localhost 3000. I'll just navigate to my browser and hit localhost 3000. So everything looks good. We are staking API tutorial, enter details, status, and build stake operation cards. Now let's connect the wallet. So I'll just connect my MetaMask wallet over here, and yep, the account looks good. So it's showing the connected wallet and amount to stake. So I'll keep the amount to stake to a small amount, 0.0001. I was able to get some more from the faucet. So I was able to get around 0.003 ETH. So we'll just uh, stake 0.0001 just to make sure that we have enough for gas operations as well. So I'll hit check stakeable balance. Okay, the stakeable balance look good with the current status. It's showing the same balance as the wallet balance as well that we just saw on MetaMask. So now let's go to the step two, which would be to build the unsigned transaction or the stake operation. So I'll just build the unsigned transaction. And even this was successful. Like you can see, it shows the current status. Stake operation built successfully with the operation ID. Operation ID format looks good. So I'll just sign and broadcast the transaction. So let's click on this button. So it's waiting for signature. So as you can see, it's showing the method as well and the various parameters. So the method is the stake method, which was decoded input data with the amount, with the network fee, and the various other parameters like data and hex. So I'll just click confirm over here, and let's check this transaction on hoodi.etherscan.io. So it will take some time to execute and index the transaction. So let's wait for this to get executed. So it might take some time. Let's wait. And boom, we were successfully able to execute the operation as well, the stake operation, and we were able to get the CBTS ETH, which is the Coinbase test stake ETH. So we were able to successfully get this as well. So this is the representation that we were able to stake some ETH as well. So we can just go to the wallet. So this was the wallet operation. So I'll just go here, and as you can see, we were able to get some CBTS ETH as well. And that's it. We were able to successfully sign the broadcast transaction as well. So basically, this is a full three-step process where we first enter the details, check the stakeable balance, and build the stake operation. And then we externally handle the sign and broadcast transaction and make sure that the transaction was successfully broadcasted to Hoodi Testnet. Congratulations, builder. You have taken the first step into programmatic staking. You learned how to set up the SDK, secure your API keys, and use the staking operation flow to create a transaction for shared staking. This is the beginning. Here's where you can go from here. First, wallet integration. The next step is to take the unsigned transactions parameter from the staking operation object and have a user sign it using a library like vm.ts, ethers.js, or a UI kit like Onchain. Second, explore other protocols. Dedicated ETH staking. For staking in full 32 ETH increments, be aware that the operation.wait can take up to 5 minutes as Coinbase provisions a new validator for you. Source staking. CDP staking API abstracts away all the complexity from Solana staking accounts, making it just as easy to integrate. Third, fetch rewards data. Use the API to query historical rewards data for building beautiful portfolios and performance dashboard for your users. Fourth, unstaking and claiming rewards. The flow for unstaking and claiming historical rewards follows the same staking operation pattern that you learned today. Fifth, understand protocol rules. While CDP API abstracts the how, you still need to know the what. Each protocol has different unbonding rules, like 3 days for Solana, 21 days for Celestia. Refer to the CDP's staking delegation guide for these crucial details. Sixth, CDP versus Prime API. The API we use today is for developers building non-custodial apps. For institutional clients managing funds with Coinbase Prime, CDP offers a Prime staking API with different features like multi-user approval workflows. For more information on the staking API, check out the official staking API documentation by CDP. Also check out docs.cdp.coinbase.com for more information on other services and products provided by CDP. Also check out Heimlash.com for more such advanced services and tutorials by Web3. If this tutorial by Heimlash was valuable, smash that like button, follow for more advanced Web3 tutorials, and share it with other on-chain builders. What would you build with the staking API? Let me know your ideas in the comments below. Thanks for building with me today. See you in the next one.